Hi guys, so in this video we're going to start looking at how the equations of our polynomials relate to the graphs of them. We're going to be using our graphing calculators a little bit, so if you want to grab that and keep that handy. We're also going to be looking at how we can interpret and find some of the features like the x-intercepts of our graphs. And we're going to learn a new term called multiplicity, which refers to when you have multiple copies of a factor like what we have here. So keep in mind, I've only given you two polynomials to look at here in this introduction. I've just written each polynomial in two different formats. Standard form, where everything's multiplied out, and factored form, where it's been factored into its components there, if you will. Each of these factors could be multiplied together after some distribution to get back to the original. So I'm going to start by putting this first polynomial. I'm going to stick with standard form to type it into my graphing calculator. So I'm going to go to y equals, I'm going to hit x to the third minus 5x squared plus 2x plus 8. Oop, that's all in my exponent, so let me try again. Let me get out of there. Minus 5x squared plus 2x plus 8. There we go. That looks better. I'm going to hit graph, and I should see this same graph that we've put on the paper there for you. But we're going to use this graph and the table actually as well to find exactly what the x-intercepts are. So think about this first. If you're going to go to the table and you're looking for x-intercepts, the x-intercepts should have what y value? Well, they should have y values that are 0 in order for them to be x-intercepts. Remember that we can call x-intercepts roots or zeros as well, and that we learned in the last section that something is a 0 if the function output at that input is also 0. So it's just like saying the y value is 0. So I'm going to hit second table, and I'm going to look for where I have y values that are 0. So here's one, and here's one. Well, what are those x values? -1, 2, and 4. So I'm going to write those down as x-intercepts, -1, 0, 2, 0, and 4, 0. And if you look at my graph, that looks like it corresponds with this picture. Here's the one at -1. Here's the one at +2. There's the one at 4. I do have 3 x-intercepts there. All right, moving on to the next graph. I'm going to clear out that equation and type in this one. X to the third minus 2x squared minus 7x minus 4. I'm going to see this graph here. Yep. And then I'm going to go to the table. Looks like I've got one here at -1 and there at 4. 4, 0. Here it looks like I only have 2 x-intercepts. Well, we should be noticing how these kind of relate to the factored form here of these polynomials. For example, the x-intercept at -1 corresponds to this factor. It's kind of like that opposite idea from our last section. If you were to solve this factor by setting it equal to 0, x plus 1 equals 0, you'd get an x value of -1, which corresponds to that x-intercept, aka that solution. 2, 0 corresponds to this factor, and 4, 0 corresponds to that factor. So if I added another factor on the end here, like say an x plus 6, think about what x-intercept you'd get. If it was x plus 6, you'd have an x-intercept at -6. If it was x minus 6, you'd have another x-intercept at +6. That's this relationship between these x-intercepts and our factors. We see the same relationship down here. X plus 1 is a factor, and -1 is an x-intercept, and x minus 4 is a factor, and +4 is an x-intercept. So that's one takeaway we should come away with, is this relationship between the x-intercepts and the factors when we've got our polynomials in factored form. Another main takeaway we want to walk away with or talk about here when we compare these two is how the graph behaves differently when we have different situations going on with our multiplicities. We're going to define the term multiplicity as meaning that you have multiple copies of a particular factor. In this polynomial, you have x plus 1 squared, which means you have x plus 1 times x plus 1. That's 2 copies of that particular factor. What happens here is different than what happens here when we just have 1 copy at x plus 1. So let's talk about these differences. Here, when I just had 1 copy, or a multiplicity of 1, all my graph did was just cross right on through at -1. It didn't do anything weird. It just crossed right on through. It was just a normal x-intercept. Down here where I had a multiplicity of 2, and I'm actually going to add this here, multiplicity 2, just kind of abbreviating. Multiplicity 2, 2 copies of this factor. What did my graph do? Well, it hit at -1, but then it bounced off, kind of. It's almost like it made like a little miniature parabola there with this as the vertex. It hit at that x-intercept and then didn't cross. It stayed. It didn't cross through to this side of the x-axis. It stayed on this side of the x-axis here and bounced is what we're going to call that. And that's going to happen whenever we have a multiplicity of 2. Let's explore real quick using our graphing calculators what would happen if I had higher multiplicities. So I'm going to type in x plus 1, and I'm going to take this factor to the third. So this would be a multiplicity of 3 copies of this factor. Let's see what the graph looks like. Interesting. Well, it hits at -1, it does cross, and it keeps on going. So it crosses, but it kind of has this little bend to it, kind of wiggles. So at x plus 3, it has that kind of bend. Let's try x plus 4. X plus 4, or x plus 1 to the 4th, excuse me. X plus 1 to the 4th. What does that do? Well, it has kind of the same bouncing idea as what we had with x plus 1 squared, where it hits it at -1 and then bounces back up. So what can we summarize here? Crossing the x-axis versus touching it, aka bouncing. Well, when we had x plus 1 to the first, it crossed. When we had x plus 1 to the second, it bounced. When we had x plus 1 to the third, it crossed with kind of this little wiggle or bend. When we had x plus 1 to the fourth, it bounced. It kind of made that kind of wider parabola that we saw. I'm going to give it away right now. If we went to x plus 1 to the 5th, it would have that same cross and bend. X plus 1 to the 6th would do the same bouncing. To the 7th would cross. To the 8th would bounce. To the 9th would cross. To the 10th would bounce. What pattern are you noticing? Well, it has to do with odd versus even. All of these where the multiplicity is odd, it's going to have this crossing effect. It's going to cross through the x-axis. Where the multiplicity is even is where it's going to bounce. And that's kind of summarized by these statements here. If the graph crosses the x-axis, then it's a 0 with an odd multiplicity. Crossing comes from our odd multiplicities. If the graph touches but does not cross, aka bounces, has that bouncing look. If the graph touches but not crosses the x-axis at a certain point, then there's a 0 with an even multiplicity. So these where it kind of bounced, those are even multiplicities. And in a moment, I'm going to do another video where we're going to explore this next example and this idea a little bit more.